we want to implement our own version of the reduce function, okay? So before we can use the built-in one. Okay, so if we were to implement the reduce function like this, we define our reduce like this, and it should take the reducer a function. Okay, so I'm just going to call it reducer, and it should take the iterable, any iterable, and optionally it should take an initial. So if I want to make this optional, what do I do? So this argument, if I want it to be optional, how do I make an argument optional? How do I make an argument optional? By giving it, now star makes it arbitrary a number of arguments, yes? You give it a default value. So what would be a default value now? We can't just put any default because it must be neutral to the operation, and we don't know which operation it is that's gonna be applied. It depends on the function sent, right? So we can just put a none as a default value. Okay, now this way, this argument will be optional. Okay, so now we have two arguments, two variables that we need to work with. The first and second. Okay, depending on whether we send an initial or not. Right? So if there is an initial, so if initial is not none, it would be something and else, if it was none, there would be something else, right? So if there is an initial, then the first would be what? And the second, the first value of the argument of the iterable. So I'm just gonna we'll update it later. So let's say the any iterable of 0. Okay. So that should be the first iteration, the first element in the iteration. Else, if we don't have an initial, so the initial was none, then first should be exactly. So the first should be the first value in the iterable, and the second should be the second value in the iterable. And then we keep looping afterwards, right? So in the loop, we need to loop over something. So let's say we're going to loop over the index in range. Now, instead of setting the second like this, we can just say that we will have the index equal to 0. Okay, because we can use this index variable in the loop. So the index would be equal to 0, and we start at 0. And here, the index would start at 1. So we start the iteration at 0 here, at 1 here. And then we can use the index as our initial value in the range. And what is the last value in the range? Last, yeah, so the length of the iterable that we set. Now inside the loop, what happens? Let me see. I think the indentation is not right. Sorry, what did you say? Okay, so I'm just messed up the indentation altogether. So let me just remove all the indentation and okay, so now the indentation of the function. Now 2 for the if loop. 2 for here. 1 for our function. 1 for the else. I mean 2 for the else. Okay. All right, so now depending whether we have an initial or not, we're gonna start the loop either at the first element or at the second element. Yeah, so where's the second element? That's a good question. That's what we're going to set here. So second equal any iterable of what? Index. So the first time, depending on the value, so it's going to be either the first, at index 0 or at index 1. Okay? So now we have the initial value for first set, and then the initial value for second set. And then what we need to do is to apply the reducer on the first and the second, right? And where do we put the result? We're gonna override the old first. So here, you know what happens here, right? So it's like when we say I plus equal 1. So we read the old value of I, add 1, and then override the old value, right? So here we take the old value of first, send it to the reducer function, apply the reducer function, and then the result overrides the old value of first. Okay? All right, and then at the end of the loop, we would have our result where? Where should we find the end result, the end accumulation? So once we're out of this loop, we finished our calculation, right? So what should we return? So we are using this first as the accumulator, right? We're accumulating all the results in that first, right? So we can just return first, it would have the final value. Okay? Now, sometimes people don't call this first. Some people would call this result, okay? Because at the very first iteration, it would be first, but every time we keep keep replacing the old first with the result of the accumulation, right? So that could be, we could call them result and the next instead of first and second. Okay. Now let's see, I'm gonna create a, let me just take this list here, scores. And we'll see how would it look like if we run this. Okay, so I'm gonna call the our reducer. I misspelled it. Okay, and the scores is what we want to send as the issue. Okay, now the function that we want to send as a reducer should be something that takes 2 arguments, right? So I'm gonna use lambda expression. It should be something that takes 2 arguments, right? You can call it x and y, first and second, sum or total, and next. Okay, just 2 arguments. And we know that the first argument will be used, or the first parameter will be used to accumulate. So we can use a meaningful name. So the accumulation would be here the total. And it just returns total plus next. If these names confusing for you, you can call them x and y, first and second, if it's up to you. okay? And then I'll print the results. So let me just try to debug this and step inside, so at least we see a few iterations and see if it's gonna give us the correct behavior here. So I'm gonna step inside this reducer. Now the reducer, the first value, the first function is a lambda function that we just created, okay? The initiable is our scores, and we didn't send an initial, okay? So initial is none. So it goes here. First, it would be the first element in the scores, and the index will be 1. So we start at 1. All right. Now starting from 1, the second would be the second element in the list, which is 70, and we have 60 as the first, right? Now we can step inside this reducer to see what happens inside. So it would, oh, this is a lambda function, it's hard to step inside it. So now the total, the result of calling the reducer is the result of adding 60 to 70, all right? And then the next iteration would add 130, which was the previous result, to 40, which is 170, and so on, okay? Now, in order for us to, just give me 1 second, So this is how it works internally. It's important for you to know how it works internally to be able to work with it. Luckily, we don't have to write it ourselves every time we need it, because there is a definition that is already built in, but we're gonna have to import it. We didn't talk about importing yet, but just like from Java, there's import that you call a thing from different libraries, right? So here we can import it from a library called functools, and then we can do the same thing. We call the reduce and give it the sum function and the numbers. It will work exactly the same as we just saw, okay? So if I brought this here, like this, and I'm just gonna send it the same function here, the same results. I mean the same iterable. It should give me the same result. All right. Okay, so that's all what we have.